where we left off yesterday. Let's see here. One bigger. Okay, so we left off yesterday. We know these are all automatically to the square root. I mentioned how to break it up into two square roots. And the idea is that we needed to have a number to the second power here and anything left over here, and then multiples of this for exponents, okay, for variables. So trick is that we had to have perfect squares. Let's see if I can do this. And the perfect squares just come from, easier to do this. So those are all squares, perfect squares. So everything we worked on had to be a multiple of one of those numbers. So in this particular case, 32 is a multiple of which one of these? 16, right? 16 times 2. So it's crucial to know these numbers very well in order to figure it out. Okay, so we had 32 is 16 times 2, right? And x to the fourth. 4 is a multiple of our root. So we can put the whole thing in there and then simplify. Square root of 16 is 4. Half of 4 is 2. Okay, or 4 divided by 2. Okay. And then what's left over, and that's it. We don't have an odd exponent, so that's our final answer. Nothing more than that. So we can do that with just about anything. It doesn't matter. Didn't really matter. But once we get down to here on number 7, now we're dealing with cubes. Now it's going to be the same deal, right? It's just now extended to cubes. However, what won't work is multiples of squares anymore. We actually have to know multiples of cubes. So that would be 1, 2, 3 times. 3 times. For 1 it's just 1, but when I apply it to everything else, okay, so we want to look for multiples of not 4, 9, 16, 25, but 8, 27, 64, 125, 216. Okay? And the same thing will happen when we have fourth roots. When we have fourth roots, we have to look for these multiples. So hardest thing is going to be shifting from always looking for, we've already really focused on perfect squares, but then shifting to, well, what's the multiples of 8? Okay, and what's the multiples of 81, multiples of 64? Okay. You'll notice the numbers are a lot bigger. They get a lot bigger, a lot faster. 10, 100, 1,000. Okay. Each of these is a factor of 10. Alright, so let's use this information to help us out here. Okay, so, oops, cancel. Let's fit, there we go. So 24 is a multiple of which of these? Again, it's a cube, so you're looking in the cube. Yeah, multiple of 8, right? So 8 times what? 8 times 3 is 24. And what's the cube root of 8? Yeah, 2. Cube root of 8 is 2. So we have 2 times the cube root of 3. Can't take the cube root of 3. Okay. Try 48. Try to do this one on your own. See what you get. Calculator's handy, right? So we have, don't forget to put the cube root symbol. So 48, what do we got? 8 and 6, okay. 8 times 6, 48, right? So a good place to start with cube roots if the number is low is multiples of 8. Multiples of 8. So cube root of 8 is 2, and then we have times the cube root of 6. There you go. Now, just for giggles, type in your calculator, what is the cube root of 48? Get the decimal. What is that?
3.634.
3.634. Okay. And now go ahead and do the cube root of 6. And then multiply that by 2. Do you get the same thing? Alright, so that's what you call a check. So if you're not sure you did it right, then you can always check at least the numbers. Whether it has numbers and variables or number by itself, you can always check the numbers part to say, well, cube root of 48, remember these are equal to each other, right? So it should be the same exact decimal, one's just reduced form. Okay, let's try it with fourth roots. Let's try it with fourth roots. Well, actually, these are perfect fourth roots, aren't they? Okay. Yeah, so if you look, let's look for fourth roots. Yeah. So, which of these, I guess it'd be 81 or 16, so I know 256 doesn't go in evenly. 81 or 16, which one goes into 243? Okay. So we got fourth root. So we're saying 16. 81. Okay. So 81 goes in 3 times. All right. So fourth root of 81 is. So what times itself 4 times is 81? 4? Yeah, 3. Remember we start with 3 here. 3 times 3 is 9, times 3 is 27, times 3 was 81. Can I freeze columns, view? I'm not going to mess with it. Yeah, so we have fourth root of 81 is 3 times fourth root of 3. Again, you can check this. You can put in your calculator just the fourth root of 243, get a decimal, and then find the fourth root of 3 and then multiply it by 3. It should be the same decimal. You can check that out. All right. Okay, I believe that will do it. Let's see here. Let's try some with variables, I guess. Okay. So 11, that'd be good. Back to cube roots. So switching back and forth between what numbers we're checking for. So we're looking at cubes, right? So 375. 125. Good. So 125 times 3. Now we want multiples of our index here, right? Multiples of 3. So x should be what? X to the... So what's the highest multiple of 3 without going over 8? Just 6. So that means we have 2 left over here. And then the y's, we can't get up to 3 at all, so that's just going to be left over as well. Okay. Here we go. Cube root of 125 is 5. Okay. 6 divided by 3. X squared. And then the remaining part, there you go. Alright, take a close look at that answer. Identify what is incorrect about it. Something very small. Yeah. So be very careful. We're so used to doing square roots. It's easy to leave that cube root off there, but it's a very different number if you take a cube root or a square root. So it's important enough that we have to check it out. Okay? Check for it, make sure it's correct.
Mr. Hodgson,
Yes.
I don't even know if it's playing really bad. It's like kind of like really bad.
Okay. Next, do we need to do another? Or do we think we got these?
You got it.
Got it. All right. Now, this is kind of useful over here. You saw how easy and fast it was to create it. All right. So you create something on your own. As needed. My guess is that you really only need it, let's see here. These are the ones you really need the most. Those are the most common ones. Ready? Okay. So let's take a trip down memory lane and switch gears to adding, subtracting. Now the idea is that they all have to be the same radical. It's kind of like the idea they all have to be the same variable. So our first goal is going to be to try to get these to match as close as possible. Okay? Try to get those to match as close as possible. So look at what do you think could be reduced. So you might point out that radical 12, that's radical 4 times radical 3. Okay. And of course, radical 4 is 2, so this is really 6 radical 3. So we have 2 radical 3. minus 6 radical 3. Now, can we write this radical 6, this last one? Can we reduce this and get a radical 3?
No.
Not really. So there's a catch on some of these, is that we can't really make them all, every single time, all the same. That doesn't help either. All the same radical. But we can some of the time. So the ones that do come out to be the same, we'll combine them together. And so what is 2 minus 6? Negative 4. And notice how it stays radical 3. Over here, it's just going to be minus radical 6. Can't simplify that to make them all the same. And that's as far as we go. Got it? Alright, so we can step it up and we can do cube roots as well. Cube roots as well. And kind of handy to have this when needed. So we want to reduce these as much as possible so they match. They actually already match a little bit since they're the same here. Okay. So we got. Actually, I might actually reduce these as they are. So we have negative 1 plus 3. So 2 times the cube root of 24. This I'll just bring down. And then reduce. What's the cube root of 24? How does it reduce? Okay. Same thing we just did. Break it up in 2 parts. What are they? So we get what? 8, right? 8 times 3. Cube root of 8 is 2, right? So this ends up equaling 2 right there. So I have 4 times the cube root of 3 minus 3 times the cube root of 2. Can anything else be done here? Okay. And when I ask that question, I'm asking, can these be combined? And as long as they're not matching, you can't do anything. They have to be matching to combine them, just like we did here and here. Once they're the same, they go together. If they're different, we can't. Kind of like if this was x and this was y. If I asked you what's 4x minus 3y, you'd say 4x minus 3y, because the variables are different. The radicals are different. Can't combine them. Alright, good. Now that doesn't mean that every answer will always have 2 parts, but that seems to be the pattern so far. Alright, so you guys can do that, whether it's a square root, a cube root, or 4th root. It's all the same process. Lastly, just have to have you remember how to distribute. These are going to be ending a little bit easier. In my opinion, this is a little bit easier to do. So what is root 3 times root 5? Just root 15, yeah. And what's root 3 times root 3? Root 9, which simplifies to, 3. Okay. Generally, you'll see it written with the real number first, not the rational number first, and then the irrational number. But it's not wrong if you do root 15 plus 3 either. Okay. So that's a more of a simple monomial, one term right here. times a binomial, 2 terms. Then we have a binomial times a binomial. That's just for distributive properties. 1, 2, 3, 4. So we have 1 times 2, 1 times that. Of course, it's 1 time, so it just turns out to be the same exact thing. It was 1 time. Now, 2 times negative 2 root 5 would be negative 4 root 5. Right, if I multiply these two together, this one and the 2. And then the last one's a little more tricky. Let's see here. It's negative 3. Notice I'm going to do the rational parts first. Negative 3 and negative 2 plus 6. And then radical 5 times radical 5 is radical 25, which is 5. So you see up here, I actually wrote out root 3 times root 3 is root 9, which equals 3. But it's possible just to say, well, root 3 times root 3 is 3. Skip the middle step there. You multiply a radical times itself, you get whatever's inside. Okay, so root 5 times root 5 is 5. Alright, so we have a little simplifying to do. These go together because they have the same one, same radical. But also 2, and this is 30, right? Those go together. So you can combine numbers together and then radicals that have the same number together. So we have 2 and 30 is 32. Negative 3 minus 4 is negative 7. I guarantee one of the most common mistakes will be people want to change this number. When you're adding, subtracting, this does not change. It's very similar to negative 3x minus 4x. You know, that just equals negative 7x. There's no squaring or anything. It's x at the beginning, it's x at the end. It's all adding, subtracting. So don't mind that it's root 5, and root 5. It's the same rules as if it was variables. Okay, so those are the examples I'll leave you with. Again, if you haven't, maybe jot this down on your paper somewhere. This is kind of useful. After a few times using it, today, tomorrow, Thursday, you won't need it anymore. You'll just be used to when it's a cube root, you'll be looking for multiples of 8, 27, and so on. Okay. Alright, so I'll leave with that. Again, tomorrow, beginning a period. And when I come around with the stamp, front and back, finish. Not trying to hurry up and do the last few, but you know how to do them and they're really easy. That makes me even more mad. That means you know exactly how to do them. You just didn't even care to spend 3 minutes before class to get it done. Or to come into the class and before the bell rings finish it. It's just kind of like, I'm not finished, but no big deal. I'm not going to worry about it because I don't really need to finish my work by the time class starts. It doesn't matter. That's kind of a poor judgment on your part. If you can finish it before class, of course you should at all costs. Okay? All right. Let you